Imagine a paperclip floating on water. Sounds impossible, right? Well, not with surface tension. Surface tension is a fascinating scientific phenomenon that allows certain lightweight objects to float on water, despite being denser than the water itself. So what exactly is surface tension? Picture this. Water molecules are social creatures. They love to cling to each other. This clinging creates a sort of skin on the water's surface. This is surface tension. It's like an invisible blanket that covers the water, strong enough to support the weight of certain lightweight objects, like our paperclip. Now, let's bring this concept to life with a simple experiment you can try at home. First, you'll need a bowl and fill it with water. Make sure the water is still and undisturbed. This is crucial as any movement can disrupt the surface tension. Next, take a standard paperclip. Now here's the tricky part. You need to gently place the paperclip on the water's surface, and when I say gently, I mean really gently. The aim is to rest the paperclip on the water's surface without breaking the skin of the water. If done correctly, you'll witness a tiny miracle. The paperclip, which is denser and should technically sink, will float on the water. This is surface tension in action. The skin of the water, created by the clinging water molecules, is strong enough to support the weight of the paperclip, defying gravity. So the next time you see a tiny insect skimming the surface of a pond, or droplets of water beading up on a leaf, remember, it's all thanks to surface tension. This incredible force of nature allows the seemingly impossible to become possible right before our eyes. Surface tension defies gravity, making the seemingly impossible possible. The power of static electricity. Ever wondered why your hair stands up when you rub a balloon on it? The answer is static electricity. Now, let's dive into the electrifying world of static electricity. It may sound like a complex scientific term, but the concept is quite simple. Static electricity is a stationary electric charge, typically produced by friction, which causes sparks or crackling or the attraction of dust or hair. Let's break it down a bit. Everything around us is made up of tiny particles called atoms. These atoms are composed of even tinier particles, protons, electrons, and neutrons. In a stable atom, the number of protons and electrons is the same. However, when you rub certain materials together, electrons can move from one material to another, creating an imbalance. This imbalance of electrons, my friends, is what we call static electricity. Now let's try a fun experiment to see static electricity in action. You'll need a balloon and some hair or wool for this. First, inflate the balloon. Now, rub it against your hair or a piece of wool. As you do this, the balloon steals electrons from the hair or wool, creating a negative charge. Now, bring the balloon close to the hair or wool. Notice anything unusual? That's right. The hair or wool is attracted to the balloon and stands up. This is because the hair or wool, now having lost electrons, is positively charged. And as you might know from magnets, opposites attract. The negatively charged balloon and the positively charged hair or wool are attracted to each other, causing the hair to stand up. Isn't that fascinating? The science behind it might seem complex, but it's all around us in everyday phenomena. From the sparks you see when you take off a woolen sweater to the shock you sometimes get when you touch a doorknob, static electricity is everywhere. Static electricity, a hair-raising experience indeed. Next, have you ever wanted to create your very own lava lamp? Here's how to do it with simple household items. Creating a homemade lava lamp is not just fun, it's also a great way to understand two key scientific concepts: density and immiscibility. Density is essentially how much stuff is packed into a certain space. In the case of liquids, some are denser than others. Oil, for instance, is less dense than water. Now, immiscibility is a fancy term that simply refers to the inability of certain liquids to mix. Again, oil and water are a perfect example. No matter how hard you shake them together, they will always separate, with the less dense oil floating on top of the denser water. So, how do these principles help create a homemade lava lamp? Well, let's dive into the steps of our experiment. First, you'll need to fill a clear glass about 3/4 full with oil. Next, carefully add water until the glass is nearly full. You'll notice the water sinks to the bottom with the oil floating on top. This is density and immiscibility in action. Then add a few drops of food coloring. The coloring is denser than both oil and water, so it will sink through the oil and mix with the water at the bottom. Now comes the thrilling part. Drop in an effervescent tablet. As it dissolves in the water, it creates gas bubbles. These bubbles are less dense than the water and oil, so they rise to the top, dragging some colored water with them. When the gas bubbles reach the surface and pop, the denser water falls back down, creating the lava effect. This movement is due to the constant battle between the forces of buoyancy, which wants to lift the bubbles up, and gravity, which wants to pull the denser water down. It's a captivating dance of science right in your glass. With a little bit of science, you can create your own mesmerizing lava lamp. Unleash your inner spy with this fun and simple invisible ink experiment. Have you ever wondered how spies in movies pass secret messages without getting caught? Well, today we're going to unravel that mystery, and the magic lies in the science of oxidation. Oxidation, in simple terms, is a process where a substance loses electrons. This process often involves oxygen, hence the name, but not always. It's the same process that turns a fresh apple slice brown when it's left out in the open air. Now, let's dive into the world of secret messages and invisible ink. For this experiment, you'll need a lemon, a cotton swab, a piece of paper, and a heat source. First, squeeze the juice out of the lemon into a bowl. This citrusy liquid is going to be our invisible ink. Dip the cotton swab into the lemon juice and write your secret message on the paper. Be sure to press down enough to leave a good amount of juice on the paper, but not so much that it tears. Once you're done, let it dry completely. At this point, your secret message is virtually invisible. Now the revealing part. Carefully hold the paper over a heat source. The safest way to do this is to use a light bulb. As the paper heats up, watch as your secret message magically appears. So, happening here? As the lemon juice heats up, it begins to oxidize and turns brown. This is because heat speeds up the oxidation process. The acid in the lemon juice weakens the paper, so it oxidizes more quickly than the rest of the paper. And voila, your invisible ink is now visible. Remember, science isn't just about facts and figures. It's also about how we can use those principles to do cool things, like writing secret messages with invisible ink. The power of oxidation, anyone can send secret messages. From the mystery of invisible ink, let's shift gears to another fascinating phenomenon: magnetism. Magnets, they're not just for sticking things to your fridge. You might have used them to hang your favorite artwork or a to-do list on the refrigerator, but have you ever wondered how they work? Let's delve into the world of magnetic fields and poles. A magnet has two poles, the north and the south, and it's these poles that attract or repel other magnets. If you try to push two magnets together, they'll either snap together or push apart, depending on which poles are facing each other. Now let's put this theory to the test. For this experiment, you'll need two bar magnets. Try bringing the poles of the two magnets together. You'll notice that similar poles repel each other while opposite poles attract. This is because magnetic fields are produced by moving charges, and these fields exert a force. When similar poles face each other, the fields cancel each other out, causing repulsion. On the other hand, when opposite poles face each other, the fields add up, resulting in attraction. Fascinating, isn't it? But that's not all. Magnets can also attract certain types of metals, such as iron. Try this out with a bunch of paper clips. Observe how they cling to the magnet. That's the magic of magnetism at work. Magnets, a force to be reckoned with. So you see, the world around us is filled with exciting phenomena waiting to be explored. Stay tuned for more such thrilling experiments. From the magic of magnetism, let's now step into a world where water doesn't just flow, it can walk too. Let's unravel the science behind this seemingly impossible feat. This is all thanks to a process called capillary action. But what is capillary action? It's the ability of a liquid to flow in narrow spaces against the force of gravity. It's the same process that helps plants to draw water from the soil. Now let's see capillary action in action with a simple, colorful experiment that you can do at home. All you need are some glasses of water, food coloring, and paper towels. Fill every alternate glass with colored water, leaving the ones in between empty. Then fold a paper towel into a thin strip and place one end in a glass filled with water and the other end in an empty glass next to it. Repeat this for all the glasses. Now, sit back and watch the magic unfold. Over time, you will see the colored water walk up the paper towel and down into the empty glass, filling it up with color. This happens because the water uses the tiny gaps in the paper towel to defy gravity and travel upwards and then downwards into the next glass. The result? A beautiful rainbow-like sequence of glasses filled with colored water. And there you have it, walking water, a colorful display of capillary action. So next time you see a plant, remember it's not just growing, it's drinking water in a way that even we can't. Stay tuned as we continue to explore the wonders of science in our everyday lives. From the wonder of walking water, let's crack open a new experiment that brings the raw excitement of science right to your kitchen. Have you ever tried to fit an egg into a bottle? Sounds impossible, right? Well, not when you have science on your side. Let's dive into this egg-citing experiment that demonstrates the power of air pressure. But first, what is air pressure? It's the force exerted by the weight of air molecules pressing down on the Earth. Now let's make this concept a reality with a simple experiment. All you need is a peeled, hard-boiled egg, a glass bottle with an opening slightly smaller than the egg, a strip of paper and a lighter. First, light up the strip of paper and drop it into the bottle. Quickly place the egg on top of the bottle. Wait and watch as the egg gets sucked into the bottle. But why does this happen? When the paper burns, it heats the air inside the bottle, causing it to expand and some of it to escape. As the fire goes out, the air inside the bottle cools down and contracts, creating a vacuum. The higher air pressure outside then pushes the egg into the bottle. And voila, you have an egg in a bottle, a cracking demonstration of air pressure indeed. Stay tuned as we continue to crack open more egg-citing science experiments in our everyday lives. Now let's move from food to drink and quench our thirst for knowledge with a bubbly experiment that's not only fun, but also delicious. Who knew science could be this tasty? Today, we're going to make some fizzy lemonade. But before we begin, let's talk about acid-base reactions. When an acid and a base mix, they react to form water and a type of salt, and this reaction is often accompanied by the release of gas, which gives that fizzy effect. Now, let's get started with our homemade fizzy lemonade. You'll need a lemon, baking soda, sugar, and water. Squeeze the juice out of a lemon into a glass. Add a teaspoon of baking soda and watch the fizz. This is the acid-base reaction in action. The citric acid in the lemon reacts with the baking soda, creating carbon dioxide bubbles. Add some sugar to taste and top it off with water. And there you have it, homemade fizzy lemonade. A refreshing and delicious demonstration of acid-base reactions. So the next time you're sipping on a fizzy drink, remember the cool science that makes it possible. Stay tuned as we continue to blend science and fun in our everyday lives. From sipping on our homemade fizzy lemonade, let's shift gears and prepare for a spectacular eruption. Are you ready to create a soda geyser? But first, let's understand the science behind it. It's all about gas pressure and nucleation sites. Gas pressure is the force exerted by gas per unit area, and nucleation sites are places where a phase transition, like from liquid to gas, begins. Now let's get our hands dirty. You will need a pack of Mentos and a bottle of diet soda. Open the soda bottle and drop a few Mentos into it quickly. Stand back and watch as a geyser of soda shoots up into the air. What's happening here is that the rough surface of the Mentos provides numerous nucleation sites for the carbon dioxide gas in the soda. This causes a rapid release of gas, creating a spectacular geyser. So the next time you see a soda, remember the exciting science that can make it erupt. Stay tuned for more exciting experiments where we make science fun and fascinating. Who needs a rainy day to see a rainbow? We can make one right at home. Before we dive in, let's understand the science behind it. It's all about a phenomenon called light refraction. Light refraction is the bending of light as it passes from one substance to another. Now let's create our own rainbow. All you need is a glass of water and some sunlight. Fill a glass with water and place it on a table. Make sure the room is dark, but there's a single source of sunlight. Hold the glass so that the sunlight hits the water at an angle and watch as a beautiful rainbow forms on the wall or ceiling. The sunlight, which is made up of different colors, refracts or bends when it passes through the water, separating into its individual colors. And that's your rainbow. So the next time you're longing for a rainbow, you now know how to create your own. Stay tuned as we continue to explore the fascinating world of science right in our own homes.